In this lesson, we will examine the slope y-intercept form for writing the equation of a line. Now this equation, 3x plus 2y equals 6, is not written in slope y-intercept form. As such, it is difficult to picture what the corresponding line looks like. Well, the line looks like this. What about the line corresponding to the equation 2x minus y equals 3? Well, once again, it is difficult to envision that this line looks like this. Now compare these two equations to equations written in slope y-intercept form, y equals mx plus b, where m and b are constant values. When we are given an equation in this form, we immediately know two things about the corresponding line. First, the coefficient of x, which we'll call m, tells us the slope of the line. And second, the constant term at the end, which we'll call b, tells us the y-intercept of the line. So, for example, if we are given the equation y equals 2x minus 3, we should immediately have a good idea of what this line looks like. We know that its slope must be 2 and its y-intercept must be negative 3. When we graph this line, we see that its slope is 2 over 1, which simplifies to be 2. And we can also see that the line intersects the y-axis here at the point 0, negative 3. So the y-intercept is negative 3. So as you can see, it is relatively easy to sketch lines when their equations are written in slope y-intercept form. Okay, now let's practice by graphing the line y equals negative 2/5 x plus 4. Since the equation is already written in slope y-intercept form, we can see that the slope of the line is negative 2/5 and the y-intercept is 4. So we now have enough information to sketch this line. Let's begin with the y-intercept. The y-intercept is 4, so the line must pass through the y-axis at the point 0, 4. Now let's use the fact that the slope of this line is negative 2/5. We know that the slope of a line is equal to its rise divided by its run. This line has a slope of negative 2/5, which we'll write as negative 2 over 5. Now we'll draw a line that has a rise of negative 2 and a run of 5. Beginning at the y-intercept, we'll sketch a rise of negative 2, and from here we'll add a run of 5. Once we connect our 2 points, we have sketched the line y equals negative 2/5 x plus 4. Okay, let's summarize. In this lesson, we learned that when equations of lines are written in slope y-intercept form, they provide two important pieces of information. In this lesson, we will learn how to find the equation of a line if we are given 2 points on the line. We'll do this by example. We will find the equation of the line that passes through the points negative 2, 4 and 4, 1. Now to begin, it might be useful to plot these points so that we can get an idea of how the line looks. Now that we have a rudimentary sketch of the line, we can see that its slope is negative and it has a positive y-intercept. This will be useful to help confirm our calculations later on. Okay, now our goal will be to write the equation of this line in slope y-intercept form. To do this, we need to determine the value of m, the slope, and the value of b, the y-intercept. Let's begin with the slope. Since we have 2 points here, we can determine the slope by using the slope formula, or using our sketch and the general definition of slope. Let's use this general definition. Now to get from one point to the other involves a rise of negative 3 units and a run of 6 units. So the slope is negative 3 over 6, which equals negative 1/2. So the slope of the line is negative 1/2, which means the value of m is negative 1/2. Now that we know the value of m, we can replace m with negative 1/2 in our equation. At this point, we're half done. All we need to do now is find the value of b, the y-intercept. How do we do this? Well, we happen to have 2 points on the line, and we know that if a point is on the line, its coordinates must satisfy the equation. So let's take one of our points, say this one, and copy it over here. Since this point is on the line, we know that x equals 4 and y equals 1 is a solution to our equation. So let's take our equation and replace x with 4 and y with 1 to get the following. We now have an equation we can solve for b. When we solve this equation, we see that b equals 3. Since we now have the value of m and the value of b, we can plug these values into the general slope y-intercept formula to see that the equation of the line is negative 1/2 x plus 3. Okay, let's summarize the steps involved in writing the equation of a line when we are given 2 points on the line. Our goal will be to write the equation of the line in slope y-intercept form. So first we find the slope m of the line. Once we know the slope, we can plug this in for the value of m in the equation. Now take one of the points on the line and plug its coordinates into the equation. At this point, we will have an equation we can solve for b. And finally, once we determine the value of b, we can write the equation of the line in slope y-intercept form. Now, if you wish to practice these steps, here are 2 points to work with. If you perform the steps correctly, the equation will be y equals 3x minus 5. Here are 2 more points to practice with, and here's the corresponding equation. Okay, that concludes this lesson on finding the equation of a line given 2 points on the line. In this lesson, we will examine the graphs of quadratic equations. Now, before we continue, I should mention that this is a very rare topic on the GRE, and it is unlikely that you will encounter a question involving the graphs of quadratic equations on test day. Okay, let's continue. To begin, a quadratic equation is an equation that can be written in the form y equals ax squared plus bx plus c, where a does not equal 0. The graph of this equation will always be a shape like this called a parabola. The parabola can be opening up, like the one shown here, or opening down, like this one. Okay, now let's look at an example of a quadratic equation. When we graph this equation, we get the following parabola. Now here's what you need to know for the GRE. First, if a point lies on the parabola, the coordinates of that point must satisfy the equation. Another property you should know is that all parabolas are symmetrical about an axis called the axis of symmetry. One example of this symmetry is that if a point is 2 units away from the axis of symmetry, the reflection of that point will also be 2 units away from the axis of symmetry. And that's pretty much all you need to know about the graphs of quadratic equations on the GRE.